Hello everyone, my name is Sumit Gaur from Pulse Technology. Today we will demonstrate formation energy in gallium arsenide. So first we have to go on our device studio user interface. So now this is the device studio user interface as you can all see. Now we will create a new project. Click OK and saved our project with name. I will save this project with name Gallium Arsenide. Click save. So now as you can all see, this is my device user interface. Now we first have to take the gallium arsenide. So go to the file option and click new. See, there is a lot of option are there in which you can take your you can import your material or device, and we will import local and 3D materials, then semiconductor, and we have to take the gallium arsenide. So see, this is the gallium arsenide. I will take this molecule and click open. Now this is our gallium arsenide, as you can all see. Now we have to first we have to find the total energy of this gallium arsenide. So we'll go to the simulator and click NanoDcal and click SCF calculation. And we have to put the parameters like 15, 15 and 15 also, and this will be a same. As you can all know, this is our SCF calculation for crystal. This is SCF input file in which you can give their input value for this particular material or crystal, in which you can select their electron temperature, energy cutoff value, its exchange correlation value. In exchange correlation value, there is a LDA and GGA type of correlation, exchange correlation are given, and in equation control, you can give their density matrix value, Hamilton matrix value. If you wanted to give some energy to this crystal, you can click it here and give their energy as well. Here you can select the maximum steps of calculation, and you can also select their mixing rate. And in basic set, you can arrange this atom or molecule by element or atom arrangement, or you can also click the Hubbard terms. If you wanted to take data into the Hubbard terms, you can click it here and take the data. If you wanted to change the spin type, there are spin types are given: collinear spin and general spin. You can also take the arrangement of by element or atom. Okay, after doing this, click generate files, and you can, as you can all see, whenever you give the input for this crystal, their SCF file is generated. Now when you open it, SCF input file, open with, and as you can all see, whatever you parameters or values you have given, all things are written in script form, in which you can see what quantity should be calculated. That is calculation dot name is SCF. their basic settings value, in which you can see the temperature, energy cutoff, their exchange correlation, what the K point values, and no spins are selected, and mixing rate is 0.1, maximum steps of calculation, and as well as all things are can be shown here. You can also see the total number of atom blocks is 2. If you wanted to change some values from here, you can directly change it, and after the change it, there is the option save, and save it. When you click save it, the input will be changed. So we have to calculate SCF for this gallium arsenide. So we have to go run option. When you click the run, now as you can see gallium arsenide job status. Now, if you wanted to see the status of your calculation, there is a job manager in which you can see our gallium arsenide SCF.input file is running. And if you wanted to see the status of your calculation, you can simply click the I button and you can see the job status is shown here. Now, calculation is still running. In the meantime, we have to take the another atom to find the formation energy. So since you can all see, we have a two types of atom, gallium and arsenide. So we have to take the gallium arsenide separately as well. So we will go to the build option and sorry, we will go to the file option and click import and go to the import online. We'll take the gallium and search it. Now go to the import option and click import online and type gallium. See, when you click the when you import the material from online and type the gallium, you can see all type of space group of gallium molecules or crystals are shown here, in which you can take the atom according to your convenience. I will take this type. I will take this gallium in which there is a four atoms are given. Then I will click add. Now we have to also take the arsenide as well. So I will go to the file and click import and import online, and I will type AS, that is the chemical formula for arsenide, and search it. And you can see there in the left side there is a full formula, and the right side there is a space group in which you can take the atoms according to your convenience. We will take this arsenine AS4 and click add. Now we have to take the we have to also calculate the SCF parameter for this gallium and arsenide. So we'll click on build option and we'll go to the simulator, NanoDcal and SCF calculation. And as you all know, in which you have to put the values, like I will put the value as the same value we will put previous. So this will be 15, 15. And you can, if you wanted to change the electron temperature, energy cutoff, exchange calibration value, you can save, you can change it from here. And if you wanted to give the iteration control basic sets, in which there are some different parameters, different values, you have to change, you should change. If you wanted to change it, you can change it. In basic set, there is arrangement. If you wanted to see data in the Hubbard terms, you can simply click on it and you will get the data. And if you wanted to see if you wanted to take the output into the spin type value, you can see take this data from this spin type, and collinear spin and general spin are shown. Okay, now click generate files. Now for this gallium arsenide, this SCF dot input file is selected. Now we have to also generate the SCF file for this gallium, so NanoDcal and SCF calculation. So do the basic setting. We'll take the values. This value will be all same, and basic set is pin type, and click generate file. After doing this, we have to run the calculation. Run, and also have to run. So now, as you can all see, uh, calculation is running, and gallium arsenide is running, and gallium arsenide is completed for the SCF input file completed. Now the next one is running is gallium crystal, and another arsenide is in cube form. After the one is completed, the second one is ready to calculate. As you can all see in the log file, log.txt file, this is the calculation status uh, file in which you can see that all the calculations are completed. And if you wanted to see for the gallium, you can go to the log.txt file, click open with, and you can see it, and you can see the calculation is running condition. So now that method, you can calculate their SCF input file. After the doing this, we have to find the total energy. So go to the gallium arsenide and go to the simulator option, NanoDcal, and analysis. In analysis, we have to find the total energy. So click on total energy, click generate files, and for we have to also find for gallium. So silicon, simulator, NanoDcal, SCF calculation. So we have to find the total energy for gallium. So go to the simulator, NanoDcal, analysis, and total energy, and click generate file. Same as for arsenide, simulator, NanoDcal, analysis, and total energy. So you can all see, as you can all see, their total energy dot input file is ready. Now we have to run it. Since in meantime we have to run the total energy dot input file. So click run and run this input. And total energy dot input file for gallium run. And total energy dot input file run. Now as you can all see, all the calculation is in Q form, and one is that is the for gallium SCF dot input file is running. After the calculation, after the this calculation, when this calculation is completed, you can see their total energy values as well. So now, in the meantime, I wanted to explain about the formation energy. How do you calculate it? So let it be running condition, and we have to minimize it, and I will go somewhere, and this is I created a PDF file, so in which you can see this is the formation energy, finding the formation energy. Since there is an equation for finding formation energy, in which you can see this is the energy of gallium arsenide formation energy, which you have to find it, is equal to energy of gallium arsenide total energy of gallium arsenide minus total energy of gallium divided over mga. Mga is stand for number of atom of gallium, minus E, that is total energy of arsenide, up over divided over NAS, that is number of atoms arsenide. So we have to first find the energy of this gallium arsenide and arsenide. as well separately. Now you can all see our all type of calculations are completed, in which you can see the SCF dot input file for gallium arsenide is completed, and SCF dot input file this gallium is now it is also completed, and SCF dot input file this arsenide is also completed, and the total energy for gallium arsenide, total energy dot input file for gallium, and total energy for this arsenide is all type of calculation is calculated completely. Now we have to see the raw data of output. So we have to first go into the MATLAB and locate this file into the MATLAB. So we'll go to the MATLAB. So I already so this is my MATLAB. As you can all see, this is my MATLAB. I located this file into the uh, as you can all see, this is the I will locate the file that where we completed this structure, where this calculation we are calculated. So this is the gallium arsenide, gallium and arsenide. So we have to open it, open all type of data. So we have to open the all file. So now, as you can all see, first we have to find the total energy of this gallium arsenide. So you can all see this is the gallium arsenide file, and this is the NanoDcal gas crystal file for this gallium arsenide, in which the total energy dot mat file and NanoDcal object dot mat file is ready. Now we have to first load the total energy dot mat file for this gallium arsenide. So double click on it, and since you can see the data is loaded, now we have to type data. So when we click the data, you can see the value is, so when you click the data, as you can all see, the value is minus 79.1892. Now for gallium, we have to load it and type data. So this is the value of uh, this is the energy of total energy of the this gallium GA4 molecule or crystal. For arsenide crystal, we have to load it and type data. See, these are the values for this gallium arsenide, gallium 4 at crystal, arsenide 4 crystal. These are the total energy of this crystal. So now we have to put this value into the our formula in formation energy. So we'll go there and open that file. I already calculated this file. So in which you can see total energy of gallium arsenide is minus 79.1892, and energy of total energy of gallium is minus 291.5387, and energy of arsenide, total energy of arsenide is minus 25.1751. So we have to put this value into this formula. This is the equation 1 in this equation 1. So when we put the equation 1, so we'll put it the value and divide over 4 and divide over, after the calculating the result, we have to we will get this data into the head tree, and when we calculate, when we convert this head tree into the electron volt, this will come about to 0.3 electron volt. So by that method, you can easily calculate the formation energy of any type of material or crystal. Okay. So thank you everyone. Thank you for watching this video.